Hi everyone, it's Mr. H here. In this video I'm going to tell you why you don't need to be afraid of fractions. They're all around us all the time. We're going to cover all about simplifying fractions, adding and subtracting fractions, multiplying and dividing, mixed and improper fractions, even some examples of where we might see fractions in everyday life. And if you go in the description, you'll see exactly the time where each of those sections starts. So here we go. Let's talk about fractions and why we don't need to fear them. So, simplifying fractions. Let me give you the first example that we're going to simplify here. And this one should be fairly straightforward for most of us. 2 divided by 4. Well, to simplify that fraction, many of us think intuitively that's a half. Well, why is that the case? Well, it's because we're dividing each of those by 2. And so we get 1 over 2. So the idea is we're trying to divide both the numerator and denominator by the same multiple. And we're trying to find the greatest common factor that we can divide each of those by. Let's look at another one, 10 over 15. The greatest common factor that I can divide both 10 and 15 by is 5. And so if we divide by 5, we end up getting 10 divided by 5 is 2. 15 divided by 5 is 3, so we get 2/3. And so you'll notice these always have to be the same numbers that we divide by. If they're not, we're changing the fraction. But if they are, then we're just simplifying the fraction. We're making it smaller numbers, which are easier to grasp. All right, let's look at a third example. 21 over 28. A lot of people have difficulty with multiples of 7, but this one is just if we divide this by 7 and divide this by 7, it ends up being 3 over 4. So that's how you do it. That's the basics of how you simplify a fraction, always dividing by a greatest common factor. Now I'm going to give you one more, and it might not immediately be clear what the greatest common factor is, but I'll show you a strategy that works even when you can't initially identify that. And so here you go. This question is 48 over 52. So you might look at that and go, okay, I know both those numbers are even, so they're both divisible by 2. And so even if you don't know that's the greatest common factor, you could begin by dividing by 2. So in this case, 48 divided by 2 ends up being 24. 52 divided by 2 is 26. And so you could look at that again and say, well, I could divide that by 2 because they're still both even. And you could do it again, and then you get 12 over 13. And 13 is a prime number. There's no factors of 13 other than 1 and 13. So that would be the answer when simplifying that one. So you notice we did it a couple times, right? We divided by 2 a couple of different times. But maybe you saw right away that the greatest common factor was 4. And if you did, because dividing by 2 twice is dividing by 4, you would have also gotten 12 over 13. So one of the nice things about simplifying fractions is you don't need to jump right to the final answer. You can kind of work step by step if you don't initially see the greatest common factor. So there you go. That's all about simplifying fractions. So now let's look at adding and subtracting fractions. Here's our first example. 1/4 plus 2/4. What does that equal to? Well, here's the idea with fractions. They must have the same denominator. The same denominator. If they have the same denominator, then you add only the numerators together. So here we go. 1 plus 2, because the denominators are both 4, is 3. That was fairly straightforward. They're going to get more complicated now. But let's see if we can apply that principle to each of the following questions. This next one is 5 over 4 minus 1/2. Or 5 over 4 subtract 1/2. Now you see the denominators are not the same. So we can't go ahead and just subtract the numerators. We need to get them to be the same. Well, what we did earlier when we simplified fractions is we divided the numerator and denominator by the same number. But if we want to divide this by 2 on 4 to get it to be the same, the 5 doesn't divide by 2, so that doesn't work. But what I can do is I can multiply the smaller denominator by a number to get it to be equal to the bigger one. And in order to keep that fraction the same, whatever I do to the bottom of a fraction, I have to do the top of a fraction. So this gives me 5 over 4 minus 1/2 is 5 over 4 minus 2 over 4. And we've got the same denominator, so 4 minus 4, that we don't subtract the denominators, we only subtract the 5 minus 2. So we get 3 over 4. Same answer as the previous one, even though we had a very different looking initial question. Let's look at another one. This one is 9 over 4 minus 7 over 6. 9 over 4 minus 7 over 6. Here we need to get the common denominator, but the common denominator, which we call the lowest common denominator, you don't have to always find the lowest one, you'll just have to simplify at the end. But the lowest common denominator, and sometimes this is known as the LCD, the lowest common denominator. Here we have a 4 and a 6. Now we can't just multiply 4 to get 6 because we have to multiply by 1.5. It's not a whole number multiple. So we can go ahead and we can list the multiples of 4 and of 6, or we can maybe even know that intuitively, but I'm going to list them here just so you see them. 4, 8, 12, so I'm just adding 4 every time. 16, 20, 24, etc. And then for 6, it's going to be 6, 12, 18, 24, etc. Now you might say, oh, 24 and 24 are the same. But remember, we're trying to find the lowest common denominator. The lowest common denominator here is actually 12. So in order to get them to both be 12, what we're going to do is we're going to multiply the 4. It's the third one, so it's going to be multiplied by 3. Whatever I do to the bottom, I have to do to the top to keep the fraction the same. And for 6, it's the second one. So I'm going to multiply that by 2. Whatever I do to the bottom, I have to do to the top. So 9 times 3 is 27 over 12. 7 times 2 is 14 over 12. And now we have that lowest common denominator. And because those denominators are the same, I can go ahead and subtract the numerators. 27 minus 14, well, that's 13. And I get 13 over 12. And I'll talk later in this video about what to do with that to turn it into a mixed fraction. But that's called an improper fraction, 13 over 12, because the numerator is actually bigger than the denominator. Let's do one more example of adding and subtracting fractions. Here's the last example of adding and subtracting fractions that I'll do now. You'll notice that here we have 3 fractions, and we need to get a lowest common denominator of all 3 of those fractions to combine them. Now you might think 3, 4, and 5, those are small numbers, but the common multiple of all those is actually quite high. We start listing them all out. If you don't see what the common multiple is right away, then what you could do is you could find a common multiple of the first 2 fractions, and then from there try to find a common multiple of, after adding the first 2 together, those ones and the one that follows. That's what I'm going to do here first, and then I'm going to show you another way that you could have done this as well. So the first thing I'm going to do here is I'm going to try to find a common multiple of 3 and of 4. Well, 3, 6, 9, 12, 15, etc. are the common multiples. And 4 is 4, 8, 12, 16, etc. And we can see that the lowest common multiple, or the lowest common denominator here, is going to be 12 of the first 2 fractions. So that means I'm going to multiply 3 by 4. Whatever I do to the bottom, I have to do to the top. We're going to multiply 4 by 3. Whatever I do to the bottom, I have to do to the top. Keep the fraction the same. So what this gives me is it gives me 8 over 12 plus 9 over 12 minus 4/5. Now because that 4/5 doesn't have the same denominator, we can't combine that yet, but we can combine the first 2. And we can just go 8 plus 9. 8 plus 9 is 17 over 12 minus 4/5. And so now that we have these 2 fractions, we can find a common denominator of 5 and of 12. And so let's list these here. I'm going to list 12 first. So I'm going to go 12, 24, 36, 48, 60, etc. And a 5, 10, 15, 20. See where this is going. We don't get anything until we get to 55 and finally 60. 60 is actually the lowest common denominator of 3, 4, and 5. In this case, 12 and 5. And so by doing this first, it made it a little easier to find that denominator. So that means I'm going to multiply 12 by 5, and I'm going to multiply 5 by 12. Now you might think, some of you are picking this up right now, you're saying, well, I'm just multiplying by the opposite denominator. And you absolutely are. Anytime you have two numbers, you can always just multiply by that opposite denominator. But that doesn't always give us the lowest common denominator and could give us some numbers that are bigger. But it will always work. So once you're simplified to two fractions, you could just do that. So that's what ends up working out as the lowest common denominator here. So 17 times 5, well, it's 5 times 10 plus 5 times 7, so it's 85 over 60, minus 4 times 12 is 48 over 60, which gives me a grand total of 37 over 60. And we can't simplify that anymore because 37 is a prime number. So there you go, adding and subtracting fractions. That's how you do it. You're always looking for the lowest common denominator. And if you can't find it, then you could just always multiply by the same number that the opposite fraction has as its denominator. The other way to do this question, as I promised I would show you, is this. If we found the lowest common denominator of 3, 4, and 5, we would have found it to be 60. And so you could have gone ahead and multiplied all of these values by whatever it takes to get the denominator to be 60. And so this would be 20 for the 3. For the 4 would be 15. And for the 5 would be 12. And so that would have given us 40 over 60 plus 45 over 60 minus 48 over 60. And then 40 plus 45 is 85. And then we'd subtract the 48 over 60 from that. And that would give us 37 over 60. So same answer doing it that way, but you could probably argue that the first way I showed you is a little bit easier, unless you can see all those factors right away in that greatest common, or that lowest common denominator of 60. All right, now we're on to multiplying and dividing fractions. So the first question I'm going to give you here for multiplying and dividing is a relatively simple one. 1/2 times 1/3. The thing about multiplying fractions is it's actually even easier than adding, because all you do is you multiply across the numerators and you multiply across the denominators. So in this case, 1 times 1 is 1, 2 times 3 is 6. That's all you need to do. Here's another one. Let's try 2/3 times 3/4. So here 2 times 3 is 6, 3 times 4 is 12. Now you can simplify this, right? Because 6 over 12 is not the simplest form. So we could actually divide both the top and the bottom by 6, and that would give us 1/2. Now you could end up doing that for a while if that's a very big fraction, dividing by another value over and over to get the simplest form. So what I want to show you now is a really, really useful way to jump right to that simplest form. And so I'm going to go back to show you again 2/3 and 3/4. I'm just going to grab a different color pen here as we look to do this. And we're going to, instead of just go ahead and multiplying across these, we're going to rewrite this. I'm going to write this out as, because the order of multiplication and division doesn't matter, I can switch these two orders, the order of the 4 and the 3. Because whether I multiply 3 times 4 or 4 times 3, it doesn't matter. So I'm going to write this out as 2 over 4 times 3 over 3. Do you see anything yet? Well, 2 over 4 simplifies, doesn't it? 2 divides into both this and this, so that becomes 1 over 2. And 3 over 3, well, that's just 1 over 1, which is 1, right? And so then we go 1 times 1 is 1. 2 times 1 is 2. So here's the principle that's at work here. Whenever you look at something like this question right here, and you can see that there's a common multiple in anywhere in the numerator, doesn't matter, it doesn't have to be the one that's above or below it, here we see there's a common multiple of 3 here and here. So what I can do is I can actually cancel that out and say, well, if I divide both the numerator and denominator by 3, that gives me a 1, and that gives me a 1. And the same thing here with the 2 and the 4. Because of the order of multiplication doesn't matter, we flipped it around here in the second way we wrote it. The order of multiplication doesn't matter, so we could recognize that this is ultimately going to be a 2 over 4. So then I can simplify this to be 1 and a 2. And then I can go directly from that step, looking at the black numbers I've written there. 1 times 1 is 1. 1 times 2 is 2. And we can jump right to that simplest form of a fraction. Super useful way to multiply fractions. All right, let's look at one more multiplication before we go to division. Let's try 8 over 5 times 15 over 12. So if you multiply this out, you go 8 times 15 is 120 over 60. And then you might be able to simplify that pretty easily and pretty quickly. But again, I want to show you a quick way to do that so that the numbers stay small and easy to deal with. The first thing I'm going to recognize is that the 5 and the 15 has a common multiple of 5. 5 goes into the 5 once and into the 15 3 times. So I can write that as really 8 over 1 times 3 over 12. Well, I can also do the same with these two numbers. I can recognize that 4 goes into 8 twice and 4 goes into 12 3 times. So now this is like 2 over 1 times 3 over 3. I'm going to write that out. You don't have to show that step, but I'm going to write it out like this just so you can see that before I cancel one more thing out. Now you can see the 3 over 3, well, that's just going to give me 1 over 1 because 3 goes into both of those once. And so really we're left with 2 times 1 over 1 times 1, or 2 times 1 is 2. So really nice how that works out. Again, the other way you could have done it is if you'd done 8 over 5 times 15 over 12. It would have been 8 times 15 is 120 over 60. And then if you saw it right away, you'd recognize, well, that's 1/2. But that would require you to, sorry, that's not 1/2, that's 2. That would require you to divide by 60. There we go. Okay, so let's look at division now. One example of division. So if you go to try to divide, what are you going to do? Let's go back to this 2/3 times 3/4. But instead of times, what I'm going to do is I'm going to replace the times with the division sign. Division is really easy. It's just one added step to multiplication, and this is the step right here. It's instead of going ahead and going 2 times 3 and 3 times 4, we have to turn that division into a multiplication. And so what we're going to do is we take the reciprocal. We take the reciprocal meaning we flip the second fraction, the fraction after the division sign. So multiply by 4 over 3. Now here we can't cancel anything out. There's no common factor in the numerator or denominator anywhere in those two fractions. So in fact, 2 times 4 is the best we can do, which gives us 8, and 3 times 3, which gives us 9. All right, so we're going to go between improper and mixed fractions and then wrap it up with an example of where we see fractions in everyday life. All right, so the first thing we're going to do is we are going to, let me get rid of that. So this next question is going to say change into an improper fraction. Improper fraction. An improper fraction is just a fraction that is greater than 1. So that the numerator is bigger than the denominator. The numerator is bigger than the denominator. So what does this look like? Well, an example would be this. 2 and 1/3. Right now, the fraction is 1/3. And we want to make it so that the numerator is bigger than the denominator. So what we're going to do, the steps we're going to do is we're going to go 2 times 3 plus 1. 2 times 3 plus 1. So we're going 2 times 3, which is 6, plus 1, which gives me 7 over 3. So that's what we're doing. We don't need to write that step down, but so you can see what I've done there. Let's look at one more example here. For whatever reason, negatives start throwing people off. But here's what I'm going to tell you about negatives. just keep this out front and do the same steps you did just a minute ago. So this is equal to negative 3 times 7, so 3 times 7 plus 4. Not minus 4, the negative is just staying out front. It's just making the whole thing negative. But the fraction part of it is still the fraction part of it. So 3 times 7 is 21, plus 4 is 25. So it's negative 25 over 7. So there you go. We just kept the negative out front and treated everything else just as we did before. What happens if it says change into a mixed fraction? Change into a mixed fraction. So a mixed fraction is where we have a number out front. So here's an example of what that might look like. It might say something like 8 over 7. So what we need to do in our heads is we need to say how many times does this denominator divide into this numerator? How many whole number multiples can I get into it? Well, here it should be obvious because we can only get 7 into 8 once. So that gives us 1. But then how many am I left over with? Well, I still have 1 more that can't go into 8. So I have 1 and 1/7. And if you multiply that back out, we go 1 times 7 plus 1 gives me 8 over 7. So it's a good way to check to see that you got the right answer. The other way to think about this is to think about when we did long division, we always did it like this. We said, okay, if 7 is being divided into 8, well, it's going to go into once. 1 times 7, well, it's 7. What's the remainder when I subtract that? Well, the remainder is 1. And so that's where we get, this is the 1 that we get out front, and then the remainder goes up front in that fraction with the 7 still as the denominator. That's another way to think about it. Last example here, negative 23 over 3. Again, we keep the negative out front, just like we did before. We're not going to do anything with it. We're just going to treat the fraction as the fraction and then plop the negative out front at the end. So we've kept the negative out front, and we're saying how many times does 3 go into 23? You could use long division to show this. 3 goes into 23 7 times. 7 times 3 is 21. If you subtract those, I'm left with a remainder of 2. So that means that I'm going to have 7, and it's negative, so the negative stays out in front, and we treat the fraction just like any other fraction. So 7, and then I have a remainder of 2/3 left over. That's the remainder. That goes up top. That's the whole number that goes out front. And there you go. That's how you'd go between a mixed and improper fraction. So with all this in mind about fractions, I want to give you a situation that I see happen at a store near me. They regularly have a sale on tires for vehicles where they say buy 3 tires and then get the 4th free. And then the next week they'll say buy all 4 tires, but we'll give you 25% off each tire. And so the question that I want to leave you with here is, which deal is better? What week should you buy the tires on? Should you buy it on the first week or the second week? You definitely shouldn't buy it outside of that because then it's regular price and every tire is $100. But which deal is better? So let's consider a little bit about fractions and percents here as we wrap up this section on fractions. Buy 3 tires at $100 and get the 4th free. Well, what you're paying is your total is equal to $100 times 3. So there you go. You're paying $300 for those 4 tires. What happens if you get 25% off a $100 tire? Well, 25% off is the same as 0.25 times $100. So how much are you getting off of each tire? So the amount you get off of each tire is, another way to write 0.25, just so we think about fractions here, is a quarter. A quarter of $100. That is $25. So that means each tire is $100 minus $25. Now some of you who are really keen on this recognized if it's 25% off, then you're paying 75% of the price. So you know you're paying $75 per tire. And you did that directly. Regardless of how you get to the results, the cost per tire is $75. And so if you talk about all 4 tires, where each is being charged $75 per tire, Here you have to pay for all 4 of them. You get a grand total of $300. It's all a ploy. A lot of people think that in situation A, that it's actually going to be a better savings than situation B. But the reality of it is, they're exactly the same. Where else do fractions come up? Well, they come up in music. Some of you who play music know all about whole notes, half notes, quarter notes, eighth notes, and so forth. When you go to a restaurant and you want to split up the bill with your friends and you want to figure out, okay, how much does each of us owe? Oh, you're using fractions. When you're baking and you want to double or triple a recipe because you have guests coming over, that's all fractions as well. So having these in your back pocket as a tool are really, really helpful to be able to do. Hope that was helpful. Please consider subscribing and hit that bell icon for any other updates that are coming shortly.